Chapter 3A and for the Oracle and SQL class. So 3A in Chapter 1, what you've done is thought about ERDs, data normalization, and how that database is really logically put together in that picture of that database. In 2, you went and learned how to develop or create tables and learned what integrity constraints were specifically, check conditions as well, and value constraints, but integrity constraints in the way of primary keys and foreign keys, and how it was important to have a primary key in one table, tie it to a foreign key in the second, and that ties those pieces of that database together. In Chapter 3A, we'll talk about how to insert data into that table that you've created. So the first slide is we want to create a script. And you'll create scripts. That's what you've been doing. A script is a series of commands that are put together into a command set, if you will, then copied into a like SQL, for instance. Now it talks about to run a script. This is how we can run a script, and we have a couple of scripts. We have 4 actually. We have Chapter 3 empty northwoods.sql file. Now that .sql file is really just a text file. All it is. A flat file. There's no particular formatting or anything within that, and we'll take a look at that. And then what we'll work with specifically is Clearwater Traders. So it's Chapter 3 empty clearwater.sql. Now, why this is laid out this way, let's step back and go to Moodle. And if I'll allow access to this at a certain point, about when we're ready to use this or when somebody needs these files. So you may not see this in Moodle for a week or so. Now, but what the deal is, these are script files. And if we just click on the script file, let's go back to here. If we just click on the script file, we can go ahead and save that file or open it in Notepad. Now we probably want to go ahead and save it. Now remember again that we want to, it'll save automatically to our downloads directory. It's a fairly small file. I'm going to go ahead and save it to the downloads directory. Okay, all downloads are completed. I'll go over here a little bit off your screen and go to my downloads directory, and I should see Chapter 3 empty Clearwater. Now what I want to do, I can run this file from anywhere, but what I really want to do is take it and copy it. The easiest way to run this is take it and copy it, and then you should be able to put it down in Drive C and then just paste it in. Chapter 3 empty clearwater.sql. Okay. Now there's a reason for that. First of all, let's go ahead and open this. Edit with right-click, edit with Notepad. And this is a SQL file. It's simply a text file. And simply a text file. Where am I at? There we go. And what's happening is it's really resetting your database. It's dropping all the tables that may exist out there already for this specific database, and we can see there's about, what is that, 10 tables, I guess? So we're going to drop all those tables, cascade constraints. Remember, that means when you drop a table in cascade constraints, that means you are cutting all those primary key and foreign key sorts of ties, those integrity constraints. And then this particular script is going out and creating a table customer, creating a table order source, and creating all of these tables that you're going to need for that database, for that Clearwater Traders database. Now, so with that said, we'll go back to SQL, and just as our PowerPoint points out, if we type in start :/chapter 3, let's go to this one, :/chapter 3 empty clearwater.sql. That means Oracle will go ahead and run that script from this location, :/. Now, the importance is that it's simply easier to run it from that root directory than from some directory folder that's way down through a series of folders. This works like an old DOS sort of system. and you can put in a quote :/, for instance, or maybe off a flash drive, drive F or something like that. Put it in the root directory is where you're going to put this file. If you put it someplace down in that directory structure, you have to say start, put in single or put in double quotes, and then the entire directory, C and Oracle and homework and all those things. So it's just simply easier to use this particular directory, and it could be your flash drive, but a top level directory, and then just type chapter 3 empty clearwater.sql. When we go back to Oracle or SQL, the SQL command line, start C:/ chapter 3 empty Clearwater SQL. Okay, it's trying to drop the table, and it's trying to drop table inventory, cascade constraints. There is no, at this point in time, there is no table by the name of inventory within my SQL setup. So what's happening is it's saying table or view does not exist. That's okay if it errors out. It's not a big deal. The next time we do this, it will go ahead and drop that table. Now you can see that we have some of these tables that have been dropped. Those are the ones we created in our last video. And then we're creating all these different tables. Now to verify this, we can type in describe, for instance, customer. And that table's been built. Describe orders. And that table is there. So we can go back and verify that this script actually loaded into Oracle. Okay, the next slide talks about DDL, data definition language. Remember, that's commands that mess with or change the structure of your table. DML, commands that works with data, manipulates data. Your select, your insert, your update commands, that works with data. Now once you change a bunch of data, there's a command called commit that saves data after it's been worked around, manipulated, whatever. That's actually a DDL command, but when you work with data, at some point you want to save it. It's sort of like saving a document in a Word. And then after you commit, you can go ahead and delete some data, you can work with it, you can do whatever, and then when you roll back, it'll roll back to this last commit point. Now, how to insert a new row of data into this table. So the syntax, and we will use a mixture of the student database, Northwoods, and Clearwater. So I've got some examples of both. Now, basic syntax for inserting into every column. Insert into table name. So the table name is like customer, values, and then column 1, column 2, and so on and so on. Now, if we go back and look at this structure, CID, C last, C first, that means we want to insert into customer values CID, C last, C first, C middle. It's sequentially. We want to insert this data sequentially. If we're adding information into every single one of these records, and we do within this course, we can go ahead and make sure that we add it sequentially within this insert command. Any numbers, there are not single quotes around them. Notice CID is a number. Any strings like Graham, Neil, R, whatever, those are varchar 2s. Okay, so you do anything that's a string or a character, you need to have a single quote around. It's absolutely, if there are 10 or 15 different fields here, you absolutely have to have that same number of fields within this insert command. Now, there's another part. Let me step back to here. Look at this date. To date, 12/10/1967, month, day, year. Remember I had mentioned that that date format, that default date format is day-mon-year. If you want to enter date information in some other format than that default format, you have to tell Oracle how it fits into this date field. So, for instance, 12/10/1967 matches month, day, and year. December 10, 1967. So as long as Oracle knows how to insert that data into that date field, it'll be fine. Okay, but if it's outside of that default date format, you have to tell it how to enter the information. So going to the next slide, this is the idea. To date, and then the I think that got slightly off, didn't it? Let me do that, and that. That's close enough. Okay, so that's how this lines up. Month, day, year. Okay, and then CC is a string in this case. 1 and 2 are simply numbers. Okay, also when we look at student values, same idea. 7/14/1985, that's a birth date, and you have to tell how that data is inserted into that particular field. Okay, now on the other hand, if you just want to use the default date format, you can go ahead and use this syntax. So insert into stuff, and I just created a table called stuff, and I'll probably present that in class, but not right here. If I just put that in single quotes, that date in that format, that would be the 13th of February 2013. It'll go ahead and enter that information without using the special to date function. Okay, so at this point, okay, we're still inserting values into this database. Now this is going to use the student table. So insert, and that student table is in the Northwoods database. So insert into student values, again, sequentially, the SID, last name, first name, and so on and so forth. Now this is pointing out simply intervals. So you can specify a year, as in Y, to month interval in a field. It's a text string, and that's the format. We won't work with that hardly at all, but some place that you might use an interval would be how long have you been in school? How many years, how many months have you been in school? And that might apply to an interval. Okay, now, so at this point, let me do this. Let me demonstrate some things. Okay, I've got a couple files set up. Not that one, this one, this one. Okay, so I know I'm using Notepad, but I probably should use Notepad++. Now, with that said though, for demonstration, notice that I have insert into customer values. I have a couple of insert lines. I have ID1, ID2, ID7. I'm going to go ahead and grab all this information, and notice you have field 1, field 2, last name, first name. The to date is just laid out like that. I'm going to go ahead and grab all of this. Come back over here to the run SQL command line. I'm just going to put some spaces in there, and then that's inserted that data. Right click into it, right click paste it. Remember, with this quick mode, properties and quick edit mode is on, and so if I do that, I can select star from customer, semicolon at the end of the command, and select what do I want to view is select. Star means everything, from which table, and it's going to be from customer. And that's the information that's in that particular field, or in that particular table, I should say. I don't care what this formatting looks like. Don't worry about the formatting. Just get the information, cut and paste. Typically, this information will be gathered or sent to a GUI of some kind, a web page of some kind, so the formatting will take place elsewhere. I just want you to get the information. Okay, now, so with that, let me do this. I need to truncate. I think this is right. Okay. Delete from, let's use this command, customer, where C underscore ID equals 1. Okay. 2. And I think the other was 7. Okay. Now in this I can recall my previous command, select star from customer. There's no rows no row selected. Okay, now what the PowerPoint does at this point, it gets into sequences. Remember I talked about surrogate keys and sequences? What this will do is create a method to insert that ID, that primary key, just on the fly automatically. So on page 107, that gives a little bit more information about this. It has to be a number field, and when you create a sequence, the default is 1 by 1, incrementing by 1, and starting with 1. There's also max and min values that you can add to this as well. So if I wanted to go create sequence customer underscore, and I do want to change to C underscore ID underscore sequence, because again it's saying create what? A sequence. The name, the sequence applies to the customer table, to the CID field, and it's a sequence. I can start with 10, I can increment by 5, and then that would go from, I think, 10, 15, 20, 25, 30 as the ID for that field. Now again, I have some examples set up. So in this case, it's the same example: create sequence customer CID sequence, increment by 5, start with 10. Now again, all these commands, create these in Notepad or Notepad++. I'm going to right click, paste. The sequence is created. Okay, now at this point, notice within my insert command, insert into customer values, and notice this, that is that sequence. Okay, that's that sequence name. .nextVal means basically plus the incremental value. Okay, it's kind of like x equals x plus 1. It is basically what this looks like. Now in this, because x is initially that sequence, x has no value to begin with, so when you have x with no value equals no value plus 1, that sequence becomes 1. When x has a value of 1, x equals 1 plus 1, well, what does x become? 2, and so on. In this case, it's going to be, because I'm incrementing by 5, it's going to be x is going to be initially 5 on that second loop, on that second time it's ran, 5, 10. Okay, now that's the idea, and hopefully those numbers will come out exactly right. Now what I'm going to do at this point, though, you notice I have customer CID sequence nextval, and I have the very same data. This is simply taking the place of this. That's all that's happening. So I'm going to go to here, I'm going to copy it. I lost it. Okay, it created the data, inserted the data. One row is created. I'm going to just up arrow to select star from customer, and as I can see, 10, 15. So my sequence worked. If you want to drop a sequence or reset a sequence, if I run this again, let me do this. If I run this data again, that sequence value is set at 15 right now. Okay, let me run this again. I'll grab this, copy it, Control C to copy it. Select star from customer, and now I have 15, 20, 25. So without resetting that sequence, it goes ahead and just picks up on the next time you insert data where it left off. Okay, so in order to reset that, you have to drop sequence, and what did we call the sequence again? This one. Okay, sequence is dropped. I should be reset back to 0 again. Now, typically what you'll do is just this. You'll start at 1, you'll increment by 1, the sequence is created. Now, with that said, let's just grab one of these records, One row is created. Now remember, we have 10, 15, 20, and 25 as records within that table. This should set that and make it so that our first record that we've just inserted should be record number 1. Select star from customer. And this record is 1. And we notice that we have that. So our sequence was reset. So I hope you understand that. I hope you see how that works. And then so we've got that sequence there. We talk more about that sequence. I've shown you all of those bits and pieces already. Follow this here as a drop sequence command. Let's see, to check the value of a sequence, you want to select cursor ID, cursor C underscore ID from sequence curval from dual. Dual is this place out there in memory that holds this information. So if I were to just go ahead and grab this command, I should be able to see what that sequence value is. I just have to copy it. That curval is 1. And that's right, because we set it to 1, didn't we? CID. And next val should be 2. There it is. So that'll tell us where we are, where we're going, and everything we need to know about the sequence. Okay, the transaction represents a logical unit of work, yada yada. Commit, we talked about what commit does. It saves that data as is. It's sort of a save with Word, like Word. And then rollback is to discard those transactions and go back to a point. What else? Okay, here are a couple of examples that we've used already. Select star from student. That means select everything from that particular table, student. You can also, for specific kinds of information, and we'll start doing a lot more in 3B, select star from student where s last equals Jones, the single quotes meaning string, a string. Okay, and then finally a little bit some additional SQL statements: updating information, deleting from a table, deleting information from a table, do some additional information about how to delete some more stuff, and then also if you have to drop a constraint, here is a command, an example that shows you how to drop a constraint: alter table enrollment, and that's the table name. Drop constraint, and this is the enrollment, the constraint name. So that should be everything that you need to go ahead and do some of these Chapter 3A exercises about inserting data. The next video will be more specifically about what the homework is asking for. Okay, thank you.